welcome everyone. My name is Qasim, and today I'm going to talk about understanding and debugging DNS in Kubernetes clusters. Before we start, I'm from Lahore, Pakistan. I currently live in Hamburg, Germany. I work as a software engineer at Microsoft. I'm one of the maintainers for the project called Inspector Gadget, the project I'm going to talk about in this presentation. I also maintain Core DNS header plugin. Apart from that, I like to contribute to different open source projects. In terms of the agenda for today's talk, I'll first talk about understanding different DNS components and request flows. Then we'll deep dive into different request flows using Core DNS log plugin, Hubble, and Inspector Gadget. Then we'll try to test our understanding using different debugging scenarios. At the end of this presentation, hopefully, you'll have an understanding of how request flows work and how they help you debug DNS issues. So to debug DNS issues, the first thing we need to understand is that there are different components. So we have an application pod, we have a node local DNS, we have kube DNS service, we have core DNS pod, and upstream DNS server. In terms of the request flow, you have an application pod making the initial request. If you have a caching agent like node local DNS, then it can answer the request directly. Otherwise, the request is forwarded to core DNS pod. If the domain you're trying to resolve is an external domain, it'll forward the request to an upstream DNS server. Otherwise, if it's a Kubernetes service or a pod, it'll be answered directly. This kind of, the flow of the request already kind of showcases different challenges there are with the DNS debugging. There are too many hidden systems. We see there are like 4 to 5 components involved, and the request can fail at any one of them. It's not easy to trace DNS request flows across the cluster. You may ask which tool to use to deep dive into these request flows. We have TCP dump, which is great for deep diving into request flows, but it lacks cluster-wide aggregation and it has no Kubernetes enrichment. So let's try to deep dive into these request flows. So the first tool I'm going to talk about is Core DNS log plugin. So it's like the Core DNS plugin, so that means you don't need to install anything. It just needs a keyword log in your core file, and what it does basically is dump all the requests to standard out. In terms of the format for the plugin, you have the log keyword followed by some names, since it has some performance hit because you're trying to dump all the requests, so you can filter, for example, by specific domains, for example, example.com. And then you can also filter by certain classes. So for example, I only care about certain, if there are some errors, then I can also filter by that. Let's try to analyze the output from one of the requests being processed by Core DNS. So in the log line, we have the client IP, which is actually my pod. You have the query ID, which the client said when making the DNS request. You have the response code, and then you have the response duration. This logging format, you have an option to configure it. So in the bottom, I have different things that you can adopt based on your use case. So the next tool I'm going to talk about is Hubble. So it provides network service and security observability for Kubernetes. It is built on top of Cilium and eBPF, and you install it as a Kubernetes daemon set. In terms of the interfaces, it has matrices, it has service map UI, and then it has flow inspection using Hubble CLI and JQ. In this presentation, I'm going to focus on Hubble CLI with JQ. In order to use Hubble, we need to install Cilium with L7 proxy support. And to enable the DNS traffic visibility, you actually need to configure a couple of Cilium network policies. One for my pod, which is like the application pod, and then one for the core DNS. Let's try to understand these network policies. The first thing I want to do is that I want to put some labels on so that this policy really applies to the pod I'm trying to observe. And then one thing to keep in mind that these policies, they also block traffic. So you need to make sure that you need to open the traffic you're interested in. So for this demo, I opened everything, but you are free to choose a stricter policy. Finally, the important thing is that you have to have some rules so that the DNS traffic will actually go through the NY proxy, so it will have the L7 information. Similar to my pod, we also have a policy for core DNS pod, and it just has a different label, but other things are pretty similar. Once you have configured everything, then at this point, you can use the Hubble CLI, the observe command, and then in this case, since we're only interested in DNS, we can pass the protocol to be DNS and then follow the trace. Let's try to analyze the output. The first line is actually the DNS request going from my pod to core DNS pod. See, it has all the query information. We're trying to resolve example.com here. Again, the domain I'm trying to resolve is an external domain. So core DNS has to make an upstream DNS request to the upstream name server. And the second line actually contains the DNS request going from the core DNS pod to the upstream DNS server. The third line is actually the response we get back from the upstream DNS server back to the core DNS pod. And then eventually, this response gets back to our my pod. This already gives a really great overview of the flow of the request, how it starts from the application pod and how it ends up then upstream DNS server and back to the my pod. One other thing I really like about Hubble is that you can run these queries with --since flag. So in this case, I'm running it for the last 5 minutes. I'm able to get a JSON output, and then I can use JQ to actually check if some pod had an issue with DNS in the last 5 minutes. Finally, the last tool I'm going to talk about is Inspector Gadget. It is a set of tools that empower users to inspect a Kubernetes and Linux system. It is also a framework that allows you to build and share custom gadgets. It can be used in Kubernetes as Kubernetes daemon set or using kubectl debug node. The core idea of Inspector Gadget is actually the idea of a gadget. A gadget is actually a shareable and runnable unit for debugging and observability. Some of the examples could be to trace DNS events, to examine drop reasons for TCP connections, or to watch which processes are being executed in your cluster. The shareability aspect of gadgets comes from that they live in an OCI registry. So you build them and then push them to different OCI registries. It has different components that include eBPF programs or WASM modules. As a user of a gadget, you don't need to care about building these gadgets because we, Inspector Gadget, maintain an official list of gadgets. You can discover them at artifacthub.com. We have our own kind there, so you can filter by Inspector Gadget, and then also filter for official and CNCF gadgets. This is the list of gadgets we maintain, and you can see already we have some other use cases here in order to detect deadlocks or similar things around that. But for this presentation, I'm going to focus on DNS gadget. What it does is it actually traces the DNS request and response using eBPF. It does the post-processing of these events using WASM. And I also have the source code for the gadget here. You can, if you have a custom use case, you can modify the code, push to the registry, and give it a try. Let's try to see the trace using trace DNS gadget. I'm using kubectl gadget, which is a crew plugin. And then you can pass it a gadget instance manifest. We'll get into the details of it later on. But once you run a gadget, you're able to trace the DNS request for a specific pod. So in this case, we are again making a DNS request to example.com. The first line actually contains the query being made, and the second line is actually the response. In terms of the definition of the gadget, like gadget instance manifest, the most important thing is the image we're going to use. So in this case, I'm using trace DNS image. Then I can have some filters. So in this case, I'm only interested in demo namespace. Just to clarify, this filtering is being done in the kernel, so it is super optimized. And then I'm trying to do some user space filtering. So in this case, I'm only interested in example.com. Lastly, the DNS gadget supports a list of fields. So I'm specifying certain fields I'm interested in. Let's try to expand the scope of the gadget, and we want to trace the DNS request not only at the application pod, but also at the core DNS. So again, I run the gadget, I pass in the gadget instance manifest, and then I generate some traffic. In this case, we can see that we have, again, just like Hubble, two requests, one from actually my pod to the core DNS, and then from the core DNS to an upstream DNS server. You can see two IDs there. Also, we have some extra information like the latency here. So you are able also to actually see how much time it is taking to different DNS requests. Again, just to give an overview of the gadget instance manifest, we have the image. We can actually name these things. And in terms of the namespaces, I'm interested in demo and the kube system namespace. And again, I include the list of fields. In this case, I include the latency here as well. So to try to summarize it, these are the different tools I personally use to debug DNS in Kubernetes clusters. You are free to choose any tool depending on the use case. But for me personally, core DNS log plugin, it's great for ideal inspection. However, the scope is limited to core DNS, and it requires configuration changes to use. Hubble provide compact overview of request flows and enrichment with retrospective analysis, but it requires Cilium CNI and specific policy in place for L7 flow visibility. Lastly, you have Inspector Gadget, which offers rich DNS traces with enrichment and filtering. It is extensible through custom gadget images. Currently, the TCP support is limited, but it should cover the use cases for node local DNS, which requires DNS over TCP. Now that we have an overview of kind of different DNS components and requests, I want to try out some real debugging scenarios to try to give a better idea. So the first scenario I want to talk about is to verify health of an upstream DNS server. In order to do that, I need to generate some traffic. So I have here a Minikube cluster. And what I'm doing is that I have a pod that is randomly generating some DNS traffic. So let's quickly try to see what this pod is doing. Okay, so it's a pretty simple pod that's just doing a lookup for example.com, sleeps for a bit, and then it actually does another lookup for unknown.example.com. Luckily, it doesn't exist, so we'll get an error. So now that we are generating this traffic, what I'll do is that I want to, again, use a gadget run. In this case, I have this gadget instance manifest that I named it as upstream DNS server. It has some filters in place, so it only cares about the responses, and only the response coming from a specific IP, which is actually my upstream DNS server IP, and then I have some certain fields in here. Let's try to run this gadget. So you can see that once I run the gadget, it's just streaming all the DNS responses. In this case, it's only putting out the responses from the upstream DNS server. And also we have here the R code, which actually helps us to establish the health of a specific domain. So for example, unknown.example.com gives a name error, and then the example.com actually gives us a success. Similarly, if you have like some issues with the upstream DNS server, you can get a server failure or something like this. So this is kind of one way to establish health of an upstream DNS server. The second scenario I want to talk about is identifying slow DNS requests in your cluster. In order to showcase that, I need to be able to simulate slow DNS requests. So what I do here is that I configure my core DNS. Just quickly. This is the core file I got. And I have here, I'm using the erratic plugin. It's also one of the core plugins. What it does is that every request that goes to slow request.org will be delayed by 1 second. So now that the core DNS, I've already configured it, what I'll do, again, I'll take a gadget instance manifest. So it's similar to the previous one. It's only looking for the responses, but it is also filtering. It only cares about the requests which are taking more than a second. Now, in this case, I don't want to just attach to the gadget run. I want to be able to observe it. So what I'll do is that I'll again run the gadget. And I'll run it in a headless mode. So that will actually you'll start to observe this gadget run. Let's quickly see if it's running. That's great, it's running. Now I need to create a dummy request. So you can see the NS lookup is taking a bit of a time. That means that the erratic plugin was doing the trick and it's slowing down the things. So now let's exit it and then let's try to attach to our gadget run to see if it actually so it actually indeed collected the any slow requests that are taking more than a second. The output is kind of a bit of crazy right now, but you are able to observe on long term, like you can run it for a day or something to kind of see if in your cluster you have any slow request. So the last scenario I want to cover is tracing DNS requests using Emperor containers. In this case, what I want to showcase is that you don't need to install anything in your cluster. You don't need to have like inspector gadget deployed, as a daemon said. You can directly use kubectl debug node to trace things. And for this demo, I'm going to use K9S, which is a TUI to help you with Kubernetes. And I need to, wow. Maybe need to restart my terminal. Okay. So here we have like a okay, great. So we have like the K9S here, and what I've done actually is I'm using the Trace DNS plugin, which is actually one of the plugins in K9S official repository. So you can go there, copy it to your K9 configuration. What it allows is that it allows you to trace DNS request by using a shortcut. So in this case, I can see different kind of pods here. So I'll just go to my DNS request pod. I can do Shift D, and then I'll just start to trace DNS request. So this is kind of how you easily integrate like tracing DNS requests into your workflow. So if you're already using K9S, you can just copy this plugin and then trace different DNS requests. Just to showcase, like this is essentially using infrared container. So it just creates a container, runs IG in it, so you don't really need to kind of deploy a daemon set or anything. Again, you can head to the node for this thing and trace all the requests for the node as well. To conclude, the first step of debugging DNS is understanding the request flows. And for that, you have Core DNS log plugin, Hubble, and Inspector Gadget. This was based on my personal debugging workflow, so feedback is highly appreciated. Finally, if you have any questions or suggestions, I put here the Slack for all these communities. You can reach them out, and they are really awesome communities. Finally, thank you so much for being here. If you like the talk, Inspector Gadget is also at the CNCF Project Pavilion in KubeCon on 2nd April. And then we're also doing a session on April 3rd on Microsoft Azure booth. And finally, we have a hands-on lab on Kubernetes Observability Simplified in KubeCon on April 3rd. That's it. I have the slides with all the policies and all the Gadget instance manifests on the QR code if you're interested. And thank you so much, and feel free to ask any questions. Yes.
Is there a way to use like any other logging stack to collect that information to centralize the logging stack?
Yeah. So. Yeah. So, Core DNS. The question is more like right now I'm more doing the troubleshooting and just outputting everything to the terminal. But if there is a way to put that somewhere else, for example, into some matrix collection or something like this. So in general, Core DNS has a way to enable matrices. So you can do that for that. Hubble also gives you a way to do it. But in case of Inspector Gadget, we also support OTel backend. So you can generate OTel matrices for like the failing DNS request and also create OTel logs for it. So we do support that. So for long-term observability. You? Yeah.
Sorry, the kubectl gadget, what does it do behind the scenes? So there is a daemon set installed on each node, something like this. It downloads the gadget and runs it on each node, something like this.
Yes. So when you do like normally you have like a first step to install the daemon set. You can do that using Helm. But we also have this kubectl gadget deploy command that can install the daemon set. So it's not like you can do the things independently, but when you do a kubectl gadget run, it actually pulls the image from an OCI registry, like unpack the eBPF program and then runs it. And the last demo I showed, I'm actually using kubectl debug node in the backend, so that's more for kind of a single node or single pod use case.
Sorry, second question, the trace DNS plugin for the gadget works also for the TCP DNS?
Yes, it works, but right now we don't do TCP reassembly. So if you have a DNS request spanning over multiple segments, it won't work, but I really hope that won't be the use case. So, but we do support parsing TCP, DNS over TCP. Any other questions? Okay, great. Thank you so much for being here, and I hope this was really helpful.